Most people imagine artificial intelligence as something weightless, a cloud of algorithms floating somewhere above the earth. But every question you ask an AI has a physical cost. From every generated image, every chatbot response, and every synthetic voice is a machine that gets thirsty for water. Across the world, enormous data centers are consuming millions of gallons of fresh water. Water that cities drink. Water that farmers depend on. Water that rivers desperately need. And as artificial intelligence becomes bigger, smarter, and more powerful, a new competition is emerging. Not for oil or rare metals, but for something humanity cannot survive without: fresh water. And a lot of people are oblivious to this. The age of AI did not begin with robots. It began with warehouses, massive buildings packed with servers. Inside these facilities, billions of calculations happen every second. Training a modern AI model requires unimaginable amounts of computing power. Those processors generate enormous heat. And heat is the enemy of electronics. Without cooling, the machines would destroy themselves. For decades, companies solved this problem with electricity and air conditioning. But AI changed the scale of everything. Models became larger and data centers became denser. The heat became extreme. And suddenly, keeping machines cool became almost as difficult as making them intelligent. That is where water entered the story. Water absorbs heat incredibly well. Compared to air, it is far more efficient, which is why many modern data centers rely on cooling towers and water-based systems. The process sounds simple. Warm water absorbs heat from the servers. Cooling systems release that heat into the atmosphere. Then, fresh water replaces what evaporated, over and over again, hour after hour, day after day. The machines never sleep, and neither does their thirst. One large AI data center can consume millions of gallons of water every day. Multiply that by thousands of facilities. Then imagine what happens when AI usage doubles, or triples, or expands to billions of people. Suddenly, intelligence itself starts requiring a resource that civilization depends on, and that's where the problem begins. Most people have never seen a data center, but they have seen and used AI applications. Somewhere, a physical machine is doing this work, and physical machines obey physical laws. Every calculation creates heat. Billions of calculations create enormous heat. Removing that heat requires energy, and removing the heat efficiently often requires water. Many facilities use evaporative cooling systems, and these systems intentionally allow water to evaporate because evaporation carries heat away, which is incredibly effective. But the water disappears. Once it evaporates, it cannot simply be reused, and fresh supplies must constantly replace it. Researchers estimate that even a single conversation with an advanced AI system may indirectly consume water. The amount might be small for one person, but AI is not serving one person. It is serving hundreds of millions. Companies are racing to build larger data centers. Governments are investing billions. Demand for computation is exploding, and every new generation of AI requires even more hardware. More hardware means more heat. More heat means more cooling. More cooling means more water. The chain is invisible, but it is very real. And geography makes the problem even worse. Many data centers are built near growing cities. Some are located in regions already vulnerable to drought. Others compete with agriculture for limited supplies. In dry seasons, every gallon matters. Communities have started asking difficult questions. Should machines receive water before farms? Should data centers expand during droughts? Who decides where that water goes? And how much intelligence is worth a shrinking reservoir? The issue extends far beyond one country. From the United States to Europe, from India to China, nations are entering the AI arms race. Each new model demands more processing power. Each new generation demands more infrastructure. Billions of dollars are flowing into server farms. Entire regions are being transformed into digital industrial zones. Electricity demand is surging. Water demand is rising alongside it. Some facilities already consume amounts comparable to small towns. Yet most people never connect a chatbot response to a cooling tower, because the digital world feels invisible. But invisibility does not mean absence. The cloud is not in the sky. It lives on land. It occupies buildings. It consumes resources. And as AI becomes embedded in healthcare, education, transportation, finance, and entertainment, demand may continue accelerating. What looks like software is becoming a physical industry. An industry with pipelines, power stations, cooling systems, and environmental consequences. History has seen this pattern before. Factories transformed landscapes. Oil reshaped geopolitics. Electricity changed civilization. Now, intelligence itself is becoming infrastructure. And infrastructure always has a price. Water shortages are already affecting billions of people. Climate change is making droughts more severe. Reservoirs are shrinking. Groundwater is disappearing. Agriculture consumes vast amounts. Cities continue expanding. And now artificial intelligence is joining the competition. The conflict is not humans versus machines. It is priorities versus limits. Because resources are finite. Communities near major data centers have begun questioning expansion projects. Environmental groups are demanding transparency. Researchers are calling for better measurements. Critics argue that companies rarely reveal their full water footprint. Supporters answer that AI creates enormous economic value. Both sides recognize the same reality. The world wants more intelligence, but nature imposes boundaries, and boundaries eventually force choices. No civilization has escaped physical limits. Not ancient empires, not industrial powers, not digital societies. Technology changes. Physics does not. The industry knows the problem exists. Engineers are searching for alternatives. Some companies are experimenting with closed-loop cooling systems. Others are developing liquid cooling technologies that reduce evaporation. Researchers are designing chips that require less power. New data centers are being built in colder climates. Artificial intelligence itself is being used to optimize cooling efficiency. Some facilities recycle wastewater instead of using drinking water. Governments are beginning to demand more reporting. Environmental standards are evolving. And competition is pushing companies to become more efficient. Because efficiency means lower costs. And lower costs mean survival. The race is no longer only about building smarter AI. It is also about building sustainable AI. The future of intelligence may depend as much on engineering as on algorithms. For decades, humanity imagined intelligence as something weightless, something that lived in code, somewhere above the physical world. But intelligence was never magic. It was always physical, and physics always sends a bill. Brains pay in oxygen, civilizations pay in energy, and artificial intelligence pays in water. So maybe the question isn't how intelligent our systems can become. Maybe the question is, how far can we sustain them? Because every civilization in history has been limited by resources. And if the next era is built on artificial intelligence, then the most advanced technology humanity has ever created may still depend on the oldest substance it has ever needed: fresh water. And that raises a question no algorithm can answer. When water becomes scarce, who should drink first?